Hi, we're Group 5, and our project is on titles of creative works and Amazon Comprehend. Here is the problem and hypothesis. I'll introduce Amazon Comprehend and titles of creative works in the data science context. Amazon Comprehend is a natural language processing service that uses machine learning to find insights and relationship in text. It can identify and categorize name entities like what is shown on the right side. The titles of creative works are built as complex name entities in the literature and pose special challenges. Here are some examples. The Great Gatsby is a simple noun phrase and it's not that complex, but the later ones are quite complex because they start with preposition, they can be an adjective, and they can be just a number. We're wondering whether Amazon Comprehend can recognize titles of creative work accurately, and does it rely on hidden variables? We experiment on many titles of creative works, and then we find some patterns. So here is our hypothesis. When recognizing titles of creative works, the performance of Amazon Comprehend is significantly influenced by capitalization, conventionality of the title's linguistic constitute, and release time of the work. Here is the significance of the project. The titles of creative works are linguistically complex, innovative, and emerging. The titles can be colloquial, they can be gerunds and infinitives rather than traditional noun phrases. New works are released every year. If the performance of Amazon Comprehend is significantly influenced by capitalization, conventionality, and release date, its accuracy and robustness will be limited. After people recognize these limitations and train further Amazon Comprehend, its robustness in an open world setting can be improved.
Okay, next we're going to talk about the collection preparation and quality of the dataset. So the dataset we're using is called Multicorner 2. It is a large multilingual dataset with 12 languages for fine-grained name entity recognition. Its fine-grained taxonomy contains 36 name entity classes, and there are also noisy instances within the dataset at a character level based on the keyboard layouts in different languages. And furthermore, the dataset has typing errors as character-based errors on keyboard layouts in different languages. So in the paper Multicorner 2, a large-scale multilingual dataset for complex name entity recognition, the researchers assessed the NER label quality for a small random sample of 400 sentences. They assessed the accuracy of NER GOAT labels, which was measured as a 94% accuracy. And we can access the data on Open Data AWS. When it comes to pre-processing the data, we first extract the entries from the dataset and concatenate the words into a sentence. So an example on the right-hand side will become a sentence like this. And we will label each entry as either 0 or 1, depending on whether the artwork title is present. And at the bottom is one example of our data entry.
So there are 5 steps in our analysis. The first is to calculate how many titles are recognized between the control and experimental group to have an overview of the comprehension. And then we evaluate model performance by comparing the confidence scores of correctly classified titles to those of incorrectly classified ones. And then we set decision threshold to 0.5 and create a column of Boolean variable to calculate precision of classification. So to be more specific, the instances with a fully recognized title when the label is correct and the confidence score is greater than 0.5 would count as a correct classification, or else it would be counted as a misclassification. Then we identify features and common patterns that cause misclassification and draw conclusion on how the hidden variables we're interested in would affect the performance of NER.
Here's an example of the type of data analysis and coding we will do. Our example data reflects all the different underlying variables we want to study. The first list is 20 famous book titles. We transform that into all lowercase letters and to sentences that begin with I'm reading. The next list is altered titles that have the same structure but different words. And the last list is books released in the past 5 years. This function uses the Amazon Comprehend detect entities feature to extract any detected titles and what confidence they were detected with. On the right is an example of the results for the lowercase titles list. This function performs the same analysis and then quantifies the total number of titles extracted per list and the average confidence scores for those titles. One thing we will improve is to make sure we only count the titles that recognize the full titles of the book, but these preliminary results will direct our study of the full data set.
So for each of the capitalization and non-capitalization group, we will draw distributions of confidence scores between the correctly identified and incorrectly identified groups to compare the confidence scores distribution, and then we also draw pie charts to display precision of classification.
And next, our workflow is represented in a chart like this. So we extract the data and pre-process the data, feed it to Amazon Comprehend, and post-process the results and apply visualization and stat analysis to it. Our final results are going to be posted on a web page and also a GitHub repository. And this page is for all of our citations. Thank you for watching.